Part 4, Using Synthetic Division to Factor Polynomials. The remainder theorem. Suppose P is a polynomial of degree at least 1 and C is a real number. When P of X is divided by X minus C, the remainder is P of C. So this is another way to find the remainder. We only need the remainder. We don't have to do synthetic division or any division. We can just find P of C. So let's use the remainder theorem to show that x cubed minus 3x plus 5 divided by x plus 2 has a remainder of 3. So if we're dividing by, it says we're dividing by x minus c, so we're dividing by x minus a negative 2. So if P of x is x cubed minus 3x plus 5, then P of negative 2 should give us the remainder. So we have negative 2 cubed minus 3 times negative 2 plus 5, which is negative 8 plus 6 plus 5, which is 3. So our remainder is 3. If we were to do that division, we would get a remainder of 3. Let's do another one. Show that 4x squared minus 1 divided by x minus 1/2 has a remainder of 0. So what we need to find is P of 1/2, if P in this case is 4x squared minus 1. So that would give us 4 times 1/2 squared minus 1, or 4 times 1/4 minus 1, which is 1 minus 1, or 0. So we have a remainder of 0 here. Another theorem, the factor theorem. Suppose P is a polynomial. The real number C is a 0 of P if and only if x minus C is a factor of P. We've talked about this a little bit before, but now we're going to formalize this as a theorem. If a real number C is a 0, then x minus C is a factor. So let's use this factor theorem to show that x squared plus x minus 12 has zeros, x equals negative 4, and x equals 3. So we need to show that there's factors to this function of x minus a negative 4 and x minus 3. Well, let's factor this. Two numbers that multiply together to get negative 12 and add together to get 1 would give us x plus 4 and x minus 3, because 4 times negative 3 is negative 12, and 4 plus negative 3 is 1. So our zeros, this is x minus a negative 4, and this is x minus 3. So we do have zeros, negative 4 and 3. Let's find the zeros here of 4x squared minus 1. With synthetic division, this is what we got. We did this in a previous section. So what are our factors? Well, this right here we get are our zeros. Here we get a 0 of 1/2. And when does this other factor equal 0? That would be when 4x equals negative 2. So x equals negative 1/2. So our zeros are 1/2 and negative 1/2. This time we have a polynomial and we're told 1, 0. So we have P of x equals 2x cubed plus 5x squared minus 11x plus 4. And we know there is a 0 at x equals 1/2. It says to factor. So we know so far one of our factors is x minus 1/2. So that's what we know so far. Let's find our other factors. First, let's divide. We'll use synthetic division. We know 1, 0 is 1/2. And then I'll put my coefficients here and use some synthetic division. Bring down the 2. 1/2 times 2 is 1. 5 plus 1 is 6. 1/2 times 6 is 3. Negative 11 plus 3 is negative 8. And 1/2 times negative 8 is negative 4. And 4 plus negative 4 is 0. We knew there would be a remainder of 0 because it's already telling us that one of our roots or one of our zeros is 1/2. So we knew we would get a remainder of 0 here. Now, what does that mean? Our other factor here is 2x squared plus 6x minus 8. So we've partially factored. We knew there was an x minus 1/2 as a factor. I did synthetic division to find the other factor. Well, I can do more. Let's factor this part. There I can factor out a 2. So I still have the x minus 1/2. And then in the second parentheses, I'll factor out a 2. And I'm left with x squared plus 3x minus 4. And then I can factor that further. I have 2, I'll put the 2 in front, and then x minus 1/2. Then how do I factor this? This is going to give me x plus 4 and x minus 1. 4 times negative 1 is negative 4. 4 plus negative 1 is 3. So we factored now all the way. So our zeros are 1/2, negative 4, and 1. X minus 1/2 is 0 when x is 1/2. X minus 4 is 0 when x is negative 4. And x minus 1 is 0 when x is 1. Here are 3 zeros, and here is our factored polynomial.